Hello, this is a video going over the R Markdown that I presented for the last R Help session on October the 5th. The main topic for this R Help session was transformation and basically showing you how to perform transformations, but also how to interpret them so that you can um, decide which transformation is the best one for a given model. So the first thing that we want to do, as always, is to import the dataset, which is imported in this way directly from online. So it's a dataset about cars, and inside this dataset, there's many different variables with a lot of data. And we will be looking at the price of a car and the mileage. So we'll go ahead and create our linear model and we'll regress price on mileage. And after we do that, this is a scatter plot of the data, which we can see is not linear, so we need to do some transformation in order to improve it. And then even if we look at the R squared, we can see that it's 66%, which is relatively low. Now, a point that I'll make here is that R squared is not the ultimate test of whether a regression model is good or not. So it is one of the things that you should take into consideration, but one thing that you always want to check are all the assumptions. So linearity, independence, equal spread, normality. So you want to check for all of those assumptions, whether you're doing a multiple or a simple regression, and also check the R squared. And that will give you the full picture of how good a certain model or transformation of a model is. So having said that, we can go ahead and try the first transformation. So as you know, transformations can be done both on the independent and dependent variables. Let's try a logarithmic transformation, and first we'll try transformations only on the independent variables. In our case, we have only one independent variable, and it's mileage. So let's go ahead and build our model. And from the scatter plot, we can see that it's still not linear, so the linearity assumption does not hold. We see that the R-square improved, but then the linearity condition is still not satisfied. So this would not be a good model. And also, as I said before, you also need to check for the assumptions. Now, one very important thing when plotting a scatter plot of the residuals is that you always want to plot residuals against the predicted y values. And this is because sometimes if you just do plot of the residuals, sometimes you might miss some important aspects of the data, and maybe for some data sets, you would assume that the equal spread condition is satisfied if you just plot the residuals, but then when you plot it against the predicted values, there might be a different trend. So always it's a good practice to plot the residuals against the predicted values. So let's go ahead and for this first model, check the assumptions. So we can see that definitely there's not an equal spread, and that the normality condition here is definitely not satisfied as well. And we can confirm this with the histogram of the residuals as well. We can see that it is unimodal, yes, but it is right skewed, so it's not very symmetric. So we can move on to the other model that we have, where we did a square root transformation on the mileage again. So let's go ahead and create our model, and we can see that the data looks more linear than the previous model, and the R squared improved again. We have 84.29% now. Checking the assumptions though, we can see that there is not really an equal spread of the residuals, so that condition wouldn't be satisfied in this case. And then the normality condition seems to be way off, so we have a large digression here from the line that we expect. And we can also confirm that with the histogram again, which is again right skewed in this case, so it has a larger tail on the right side here. Now let's try combining a transformation of the independent and dependent variable. So let's try the same transformation for both variables first. Let's try the logarithmic one. So we create a logarithmic transformation of the price, and then we already have calculated before in this R Markdown file the logarithmic transformation of the mileage. So let's go ahead and create our model and then plot get a scatter plot of the data and then check for the assumptions. So first we have the scatter plot of the data. We can see that it's definitely not linear. And then the R-squared value is pretty low, even lower than the original data. So that's definitely not good and not what we want in a model. And then the scatter plot of the residuals against the predicted Y values does definitely not show equal spread. And then the normal condition is also not satisfied because again there's quite a bit of points here that go quite far from the line that we expect. And we can confirm that again with the histogram, which although is unimodal, it's not symmetric because it is in this case left skewed. So here again all the assumptions are not satisfied. And we have a low R-squared value, so this is definitely not a transformation that we want to do in this case. Next, let's try a square root transformation for both mileage and price. So we create our square root transformation of the price, and then we create our model just similarly as in the previous case. So first, let's check the scatter plot of the data. It definitely looks linear, so we could say that the linear assumption is satisfied. There are some outliers there, but on average they seem to be around the linear trend of the data. Now we can see the R-squared value is quite high here, but this is a good example of why you should not consider only the R-squared value when deciding if a model or if a transformation is good or not. So here, judging only by the R-squared value, this is the best transformation possible for this data set because we will encounter no higher R-squared value in this R Markdown. However, look at the plot of the residuals against the predicted Y values. We can see that this is definitely not equal spread because we have a high concentration of points here and almost no points below the line. The normal condition, we can consider it satisfied because again this can be subjective, but there seems to be an equal deviation at the start and at the end at both sides of the line, and it seems to be closer to the line than in the previous cases, but still there's a big question mark on the normal condition. And the way to check this, if it's not obvious in the normal QQ plot, you can always have the plot of the histogram as well, which will confirm or disprove your assumptions or your conclusions about the validity of whether the assumption is satisfied or not. So if you look at the histogram of the residuals, we can see it's unimodal, but it's a little bit right skewed. So in this case, actually, we would say that the normal condition is not satisfied as well. So here we can see all the conditions except the linearity one are not satisfied, but we have a high R-squared value. So it's a perfect example of why you should not have R-squared as the ultimate measure, as the ultimate and the only measure actually for the appropriateness of a linear model. So let's try now a cross combination of a of transformations for the independent and dependent variable. Let's have a logarithmic price and a square root mileage. So after we build our model very similarly to the previous cases, we can see that the data is linear. There are some outliers here, but in general, there is not a large deviation from the linear trend. And then we can see that the R-squared value is reasonably high, 84.76%. And now the equal spread, this actually looks like there's the most equal spread from all the transformations that we've seen. And we can say, except for these points, but remember, for equal spread, you're trying to see where the bulk of the points are distributed. So we can see that a large portion of the points are distributed in this area right here. And we can see that they are equally spread above and below the line. Now this is questionable whether this plot shows us whether we satisfy or not the normal condition, but we can see the deviation here is only 3, and in the other cases it was much more. So again, if you have doubts, just plot the histogram and use both to assess whether the normality condition is satisfied. Now here we can see it's almost perfectly symmetrical and we have a unimodal. So definitely we can conclude that by looking at the histogram of the residuals, that the normality condition is satisfied and the equal spread and the linearity conditions are satisfied, and we can also say that the outlier condition is satisfied as well. And we have a high R-squared value, so this is by far the best candidate for the way in which we want to do the transformations for this data set. And finally, just to be consistent, and to be inclusive of all the possible transformations that we can do, let's try one more combination that's possible, and that's a square root price with a logarithmic mileage. And for this transformation, we can see that definitely the linearity condition is not satisfied, and the R-squared value, it is relatively high, 75.43%. However, the equal spread condition is definitely not satisfied. The normality condition seems satisfied, but look at the scale. This is much more deviation from the line than in the previous case. And we can confirm it with the histogram as well. Of the histogram of the residuals is unimodal, but it's right skewed. So by far, the logarithmic price and square root mileage is the best transformation that we can do for this data set. And again, one more thing to note for the end, do not, I will repeat, just consider the R-squared value to judge whether a linear model is good or no. So you should take it together with the assumptions, and if all the assumptions are satisfied, then you look at the R-square model between models which satisfy the assumptions. So here, basically only this model, the best one, satisfied the linear assumptions. And although it has a lower R-squared value than 89.66, I think it was. So it doesn't have the higher R-squared value, but it satisfies all the necessary assumptions. And in this case, if we were going to proceed and use the linear model, we would choose this transformation of it.